Yeah, so an introduction to DAFNI. As I said, I'm Brian Matthews, so I lead the DAFNI project, the development and hosting team in the Scientific Computing Department at the Platform Laboratory, part of the Science and Technology Facilities Council, all a bit of a mouthful, and I'll explain a little bit about our role later. So, firstly, what are we trying to do with DAFNI? Well, what are the problems we're trying to solve? Well, infrastructure is a very active area of research, as you surely all know. It's becoming increasingly like most areas of research, sort of computer oriented and data oriented, more and more data being used, more and more simulation being used. And this leads to problems. You know, there's more and more data that we need to combine together into models and simulation. We want more higher resolution, both more detail, but also wider geographic scope. We need more and more compute resources for this, and this can be challenging for individual research groups. And then we want to build on that. We want to be able to bring data from different places to integrate it together. We want to be able to integrate data from different domains, from energy and water and land use, bring them together into the same model. So we have a big issue here about how we actually go about integrating data, what we need to provide, the common standards we need to do for that interchange and interoperation. We need to respect any security or licensing conditions that comes with that data. So that becomes a big technical challenge in itself. And then we have these models that we want to build to describe infrastructure, and they become increasingly interdependent. You know, we want a water model, or we want an energy model, we want to have them work together. And we want to be able to integrate those across scales. We want to be able to integrate from an individual building or individual street right through to a city, through a region, to a whole country, and also across sectors, not only between water, energy, land use, digital transport, the kind of infrastructure areas, but also with the wider natural environment and economic and social environment we want to interact with to do these to actually get the impact of our infrastructure research. So all of these are giving us more and more computing challenges to conduct the research. And if we want to extend into newer types of research like digital twins, we've got to do extra layers on top of that about how you connect to sensors, how do you manage an architecture that's taking real-time interaction with the environment, and and comparing that with analyzing historical data. So we're getting increasingly complex computer problems in infrastructure research. And this is where DAFNI comes in. DAFNI is the Data and Analytics Facility for National Infrastructure. And what we're trying to do is provide a computing platform to support that decision making for national infrastructure research. So we're going to give it a common point or a common platform which we can bring together data and models in a common computing platform, and people can share and use those in one place. And it represents and it is being driven by an £8 million investment from the UCRIC programme, the UK Collaboratorium for Research and Infrastructure in Cities, which has been running since 2017 and runs to 2021. And the DAFNI is formed by a consortium of 12 universities, including Imperial College, and that's led by the University of Oxford. Aruna is the member of the governing board, the PI, the co-I from Imperial, and ourselves, STFC at the DAFNI Laboratory, were asked to be the development host and the host partner of this, to actually do a lot of the development of the platform. And if you don't know us, we're a scientific laboratory that specialises in supporting research infrastructure for the UK academic community. So what does DAFNI try to do? Well, it provides a high performance computing platform. I won't go into this, but there is a hardware platform underneath it all, which we host. And on top of that, we're building a software layer, which is then going to produce a secure repository where we can put both data from diverse places, and also the models that people are producing in different projects, and bring them all in one place, and then provide an execution environment, so where people can collaborate, they can take those models and data that are provided from elsewhere, do new research by combining those in new ways, accessing the high performance computing platform to scale them up, and then hopefully make those available for the long term, so that beyond the lifetime of any one particular project, we can continue to provide a place for reproducing that research and doing new research using those models. So what's the platform composed of? Well, we'll see some demos later, but these kind of give some indication of the areas that DAFNI is supporting in its functionality. Firstly, there's a logging area, so there's a security system which respects the licensing, but also seeks to make data openly available and shareable at the same time. And then within that, we've got a data catalog, so we can store data sets. People can upload data from various sources, and then they can browse and look for what data that's been made available to them. They can look at particular data sets, access particular data sets, download them if they have the right permissions. And then there's an area where we can upload models and execute models, and then build them into more complicated workflows, so we can combine models together. And then finally, a visualization area where we can develop more advanced visualizations. This is an area that we're still working on. We have this partially working, but there's still additional work done on visualization in particular. So focusing on a couple of those areas, DAFNI forms an information infrastructure, a data hub, where we can share data, we can do data integration and data curation. There's a component which is called the NID, or the National Infrastructure Database, which provides a trusted, secure repository to hold that data. And then we can bring in data from elsewhere, and the intention is that we will also be able to link data from elsewhere into that space. So that's the long-term intention of this. There's a metadata framework underneath all this, based on a very common standard called DCAT2, which allows us to describe data in a very general way from lots and lots of different sources, and give a common search and access across them. And this gives us a platform which is integrating and combining data from different sources as a sort of information management framework. The CDBB, a digital twin hub, is talking in terms of building information management framework for digital twins. We would see that we would support that as a sort of layer that allows us to integrate data from different sources and make it available to different people. So that's the kind of the data side, and we'll see a demonstration of that later from Beth. On the other side is the major area is the user modeling side, which we call the NIMS, or the National Infrastructure Modeling Service. And this allows us to people to upload models from lots of different places. So essentially, what we've done is try to make it independent from the programming languages and tools and libraries that people use when they're writing their code. What we ask them to do is what's known as containerization, using a system called Docker, which kind of encapsulates their codes into a unit or a container, which we can then upload into our system, and then make that accessible to the data which we have and execute in our environment, and combine with other models, even though they may be written in other languages and in other libraries. It allows us a ways to be independent of that code, but still allow them to share and execute them within the same security framework, and then they can be run on our high performance or high throughput computing cluster using a system called Kubernetes, which allows us to orchestrate the containers together, sort out the execution. And this allows us to scale up, access data in the NID, and access visualizations. We can then take those models and chain them together in more complicated ways to build workflows, to do this sort of interaction between different models and different places. So this allows us to do these key features of the an infrastructure ecosystem, coupling from different sectors, coupling across different scales. I guess finally I'll just kind of give a few examples of the kind of things we've been doing. So this is an example. These are a couple of pilots, pilots we've done where we've uploaded a model from the University of Southampton that does station demand. So this looks at where you want to locate a new railway station and looks at the impact of where the passengers will come from in the local areas to come to use that station, so you can best locate the station on the line. This model on the right from the University of Leeds is looking at economic impact and demographic change based along the Oxford-Cambridge corridor. So you put in new railway lines, new road links, you see what's going to happen to the economy and to where jobs are in that corridor. We're also working very heavily with the University of Oxford on quite a complicated model called NISMOD, which combines a number of different models together into a systems as systems model, looking at energy, transport, digital infrastructure, water and waste. And this is being used for infrastructure planning across the UK, but again, doing a lot of work with the Oxford-Cambridge ARC. And again, it allows us to manage risks, look at the risks involved in interactions between the different models. This is still somewhat of a work in progress. It's very complicated. It's nearly ready, but there's still some final tweaks to be done on that. And my final example is a pilot study we're doing with the University of Sheffield, looking at bringing digital twins onto the platform. It's an area that was not really when the project was first conceived 6 years ago, was a very new area, wasn't really much in the focus of the project. It's gradually growing in importance during the project, and we're sort of adapting to provide features for that. So this is a kind of an attempt to do a digital twin where we have a large number of sensors around the city of Sheffield in their urban observatory. We're looking at traffic flow, and we're building, and Christian Jeans and Daniel Coker from Sheffield are building an AI-based model to update that in real time from each sensors, and then try to predict what the traffic is going to be over the next 30 minutes, and then feeding that back to Sheffield, potentially feeding that back to Sheffield to maybe control their traffic flows. So that's kind of a quick overview of DAFNI. Where are we now? Well, I mentioned earlier we've been in a development phase that goes on until next year. Next March, though, we are looking at a short extension into the middle of next year, into next summer, where we've been doing a lot of very recently been very, very intensive development phase. There also is an investment of hardware across universities, including at Imperial, where we put in a number of different hardware units in the 12 partner universities. That's still ongoing. We'll be doing a lot of pilots. I've just shown you some of them, and we have what's known as champions, where we've been working with particular individuals in particular universities to work on particular pilots, and also do a lot of outreach activities in those universities. And beyond that, we're doing a very large amount of outreach in lots of webinars, including this one. We have hackathons, and we have a final event planned, which was originally planned in March, but we're looking at pushing that back into maybe June next year. And then beyond that, we're developing our sustainability plan. We have a DAFNI phase 2 sort of planned, where we will be running into operations next year. So we're kind of developing our plans and how we're going to do that, with a mixture of platform support, where we hope to be free at the point of use for kind of normal academic use, but also having contributions from projects and elsewhere. And then in that kind of phase 2, we want to develop some of those ideas that we've been talking about, more on digital twins, richer data infrastructure, potentially things like machine learning, and develop this kind of integration of models and data and curation of models further. So very happy to discuss further collaborations in and after this meeting. So my final slide, yes, just to summarize, DAFNI is an environment or an infrastructure to support research in infrastructure systems across domains and across researchers, government and industry potentially, with a HTC platform to support research, data sharing across with a common infrastructure and allowing us to scale and couple models. Still a lot of work to be done, particularly digital twins, in dynamic data management framework and data ontologies, but nevertheless I think we have a very strong basis to support sort of research into the sustainable development of infrastructure into the future. So